Claim amounts are independent. In year one, claim amounts are normal variable X with mean 100 and standard deviation 25. In year two, claim amounts are Y when Y is equal to 1.04x plus 5. Calculate the probability that a random sample of 25 claim amounts in year two average between 100 and 110. So X is normal and Y is a linear combination of X. So a linear combination of a normal variable is also normal. So Y is also normal. And we are focused on Y because we're talking about 25, average of 25 claim amounts in year two. And that's why Y is the claim amount in year two. So by central limit theorem, if nu y and sigma y are the mean and standard deviation of each of n identical normal variables, then the mean and standard deviation of the average nu of y bar is the same as nu of y. And nu of y will be 1.04 times nu of x plus 5. And nu of x is given to be 100 in the beginning of the problem. We're told that the mean of x is 100 and the standard deviation is 25. So nu of y bar comes out to be 109. Sigma of y bar, again by central limit theorem, is sigma y divided by square root n. So let's first calculate variance of y. So y again is 1.04x plus 5. So the variance, you know that variance of ax plus b is equal to a square variance of x. And this doesn't affect the added or subtracted constant, doesn't affect the variance. So variance of y will just be 1.04 square variance of x. And standard deviation of x was 25, so variance of x is 25 square. So that's variance of y, and then the standard deviation of y will be the square root of the variance. So that would just be 1.04 times 25, and that's 26. And therefore, now from this equation 1, we can calculate sigma of y bar. That's sigma y divided by square root n. Sigma y is 26, n is 25. So square root of 25 because they're told that the average of 25 claims. So that's 5.2. So now we have the mean and standard deviation of y bar. And the question was to find the probability that the average of second year was between 100 and 110. So y bar between 100 and 110. So therefore we'll need to change the 100 and the 110 into z-scores. So z of 100 would be 100 minus nu y bar over sigma y bar is equal to 100 minus 109 over 5.2 equals negative 1.73. And similarly, z of 110 will be 0.19. So probability y bar between 100 and 110 is the same as probability z between negative 1.73 and 0.19. And that's probability z less than 0.19 minus probability z minus z less than negative 1.73. So this one can be read from the table, but this one needs to be changed. First, we need to take care of the negative. So z less than negative 1.73 by symmetry is the same as z greater than 1.73. And then again, we need to change it into less than in order to use the cumulative table. So z greater than 1.73 is the same as 1 minus z less than equal to 1.73. And now we have everything from which we can read from tables. So let's see. So for 0.19, we see that it's 0.5753. 0.5753, and for 1.73, we have 0.9582. And it all comes out to be 0.53. That's choice B.